Welcome back to AlgoJS. Today's question is LeetCode 766, Toeplitz Matrix. So given an m by m matrix, return true if the matrix is Toeplitz. Otherwise, return false. A matrix is Toeplitz if every diagonal from top left to bottom right has the same elements. So here an example, as you can see, the diagonals going from top left to bottom right are all the same. So we have 5 here, 1 is the same across, 2 is the same across, 3 is the same across, etc. And in example 2, this is not the same, so we can return false. So initially, the best way to solve this is to map out the indices. So I is equal to 0, I is 1, I is 2, j is equal to 0, j1, j2, j3. Now if we map them out, so if we have 0, 0 here, we have 1, 1 here, we have 2, 2 here. And then if we increase that by 1, we have 0, 1, 1, 2, 2, 3. So as you can see in the diagonals, we are increasing by 1 and 1 in terms of I and j. Again, we are increasing by 1 and 1 in terms of I and j. And it's the same with these values too. So I is increasing by 1, j is increasing by 1. So we need to compare matrix at ij with matrix at I plus 1, j plus 1. Okay, we're going to be comparing, say this is matrix at ij. We're going to be comparing that with this, which is I plus 1, j plus 1. And if they aren't equal, then we are going to return a Boolean. So we are going to return false. Now there's only one issue, there's only one edge case with this solution. And that is once we get to, say, this value, say this is matrix at ij here, we're automatically going to compare it to matrix I plus 1, j plus 1. And this is going to be down here and it's going to be undefined. So this will return an error and it won't pass the test cases. So what we need to do is we need to reduce the search criteria so that it only goes up to matrix.length minus 1. So I needs to be less than matrix.length minus 1 and j needs to be less than matrix at 0.length minus 1. That way, we'll exclude this section and this section. So matrix at ij will only go up as far as these values. That way, when it compares, so when this 5 compares to this 5, this is always inbound. Same with this 1, it is inbound. The same with 2 here. The 2 is inbound and it's never going to go to the next row or the next column because we have defined in the search criteria in the for loops that it should be less than matrix.length minus 1. So that's the general understanding of solving this problem. So the time complexity for this one is going to be m times n, where m and n are the number of rows and columns within the matrix, and then space in this case is going to be O of 1. So let's write this out. There's not much to this code. So that I equals 0, I is less than matrix.length minus 1. So we're reducing that search criteria. Then we'll do the same for j. So j is equal to 0. J is less than matrix at 0.length minus 1, j plus plus. And then we need to check if matrix at ij does not equal matrix at I plus 1, j plus 1. Then we can return false. Else we can return true. Okay, let's submit it. And there you go.